Welcome everyone to question number 3, bottom view of binary tree from the topic trees in Geek for Geeks must do coding interview questions. Just have a quick look at the question and we'll be discussing the approach soon. But before that, don't forget to subscribe our channel. If you have any extra email IDs, please do subscribe with all those IDs. That will be very helpful for our growth of the channel. And if you have any doubts, leave a comment below where you're facing the problem and we'll be very quick to respond. Now let's go to the approach part. Before we dwell into the coding approach, we have to know the meaning of the question first. The question is saying we have to find the bottom elements and print it in a left to right order. So how can we do that? Printing the bottom element from left to right order. So for that we have to know what is exactly a bottom element, right? If I draw this diagram roughly, 8 may be in the left side. Okay, from the bottom you can assume this is 5, then 8 is a right, then 10, 14 and 25. From this you can see 5, 8, 10, 14, 25. You can see from the way I have drawn, it seems like 5, 8, 10 and 3, this one, 3, 14, 25 are the elements, right? But it may not be exactly correct, okay? Sometimes you can say exactly 5, 10, 3, 14, 25 bottom elements. Sometimes the elements will overlap and you will be confused. So you won't know what are the bottom elements. Okay, from the by the meaning of the question, we have to find the bottom element. Now there is a way for finding out a bottom element, that is a called horizontal distance approach. What we do in this horizontal distance approach is we start from the root node here. Okay, the root node will be starting from 0 index. Just assume it as a given number as 0 here. Okay, now we will be doing the same thing in the coding also. Now after giving this 0 value to the root, now we'll be checking level by level. Okay, level by level we'll be checking the same horizontal distance. Now for the left side we have to do -1. For the right side element we have to do the plus. Okay, now do this for all the elements and you will be getting some values here. So for 5 we get -2. Okay, -1 and -1 will be -2. -1 plus 1 will be 0 here, and +1 and right side is +1 again, so that will be +2 here. Similarly here for 10 it will be -1, for 14 it will be +1 here. So if you look carefully, we have got some digits here. Okay, you can assume it as the index key variables. So if you take this uniquely level by level, we have to take the last level integer, the last level index. What do I mean by the last level index is we have to take only those elements which are repeating at the last level, right? For -2, okay, let's write down for -2 how many elements we have. For -2 only we have 5 here. Okay, this is fine. We can simply print 5 in this case. But for -1 we have 10 and 8 also. Now how will we choose what is from 10 and 8, which element should we print as a bottom element? So that element will be chosen which is repeating at the last. Since first we got 8, later we got the 10 part, so we'll be choosing this 10 here. Similarly we do this for all the other indexes. So by using distance approach, we can name each value a particular index. Okay, and the benefit of doing that, we'll know soon what is the benefit of doing that. So -2 -1, next is the 0 index. For 0 index we have 3 and 20, and similarly here 3 is the last repeating element, so this will be the final answer for printing. Okay, now 1 is there and 2 is also there. For 1 we have 22 and 14 and 22. 14 is the answer because this is the last repeating element here. This is the element which is coming after 22. Similarly for 2 plus 2 we only have one element which is 25, so this will be obviously the answer. Now the answer will be in a ascending order of the indexes that we have represented as horizontal distance. We will represent this as HD, as horizontal distance. Now level by level we will be checking the horizontal distance index. Okay, if the index is same, we will just replace the element with the next one. In this case there is no replacement, there is only one value, so we'll just directly take this in a hash map. Okay, in hash map we will store these indexes. Even if the element repeats, we can just replace the value of the key index HD here. So in this case only 5 is there is no repeating element, so no problem here. So but in -1 case we have 8 and 10. First 8 will be entering the hash map. Okay, now after checking level by level and we come here, a level is the last level. So level is greater than the previous level, we check for that particular index. Then we just replace the 8 value with 10 here. So 10 will be there in the final value. Similarly 3, 14 and 25. All of this will be there. Now if we use hd dot keys, okay, in dictionary we use dot keys method, right? The dot keys method, if we use this dot keys method, we will get all the index values, or you can say the key values in a ascending order. So we'll getting -2, -1, 0 and 1, 2 if we use this dot key method. After using dot keys, we iterate using a for loop. Okay, after iterating in a for loop, we will be printing or storing this element in a list, and we will be returning that to a function. So now if we use ascending order, and let's just print those numbers, or you can assume we are appending this to a list. So 5 is there from the first -2. In -1 we have 10, 0 we have 3, then we have 14, and then we have 25 at the last. So this is the way or approach to this question, and this will be our final output. Okay. If any other questions come from this bottom view of binary tree, you can take your notebook and just write down +1 from the right side and -4 from the left side, and we will be starting from the root of 0 index. You just repeat this method, you will get the answer. And this is our final output. I hope you have understood till this part. If you still haven't understood, and if you still haven't understood, let's go into the coding part, and that will be very much clear what is happening after viewing the coding part. Now let's go into the Geek for Geeks website and view the coding part. Now we are inside the Geek for Geeks website here. Now this is a function that we have to write here, bottom view function. This L will be our final list that will be giving to the function after adding all the bottom elements. And this is a dictionary for the using, and this is a dictionary used for hash mapping. Okay, and we are also using another function for separating the characteristics here. Okay, and we will be giving root element and a dictionary element here, and we'll be giving the hd value. Okay, horizontal distance 0. I told you will be starting from 0 index from the root, right? So we're giving hd 0 as an initial stage and level 0 as an initial stage. You can also give level 1 also, that will also work. For now we have taken 0 index for the level order. So level order will always update 0, 1, 2. So this is 20, this will be 0 level, this will be 1 level, this will be 2, and this will be 3. Right, for that order this is used for level, and this function is used for getting the values from the keys after storing in the hash map. That will be our bottom elements, and we'll be returning that. Okay, let's have a look at the print bottom view function here. Okay, in this function what we're doing is we are checking if the horizontal distance or the index that we have mentioned, 0, -1, +2, -2 are there, right? Those indexes we are checking if it is present inside our hash map or not. If it is not present, then we just simply give the data of the current element level by level order. If the element is present, okay, for example, the element is present for the given index, right? We have mentioned the presentation that their values are repeating. Sometimes two values can be repeated, sometimes more than two values can also be repeated. So in that case, we check the condition, the level is equal or greater than the previous element. Okay, previously whatever the level was there, we'll comparing with that. If it is same or greater, then we replace that element with a new element, which is our new bottom element. Okay, there can only be one element for each index. There cannot be more than two elements or two elements. Okay, so this is just storing the bottom elements. Okay, this case is used for using storing the bottom elements only, and we are recurring the function again and again. Okay, this one will be used for left recursion, left side tree, for iteration of the left side tree, and this will be used for the recursion of the right side tree. Okay, and one by one we will be checking each time the iteration is finished like that. And if we reach the root value as none, or the if we reach the leaf element which will be none, okay, in that case we return and the function will be stop working, and we'll get all the values inside the L variable here that we have mentioned, and that will be written as our final output. After seeing this code, I hope you have understood totally what is going on in this. If you still haven't understood, just mention your doubt in the comment section. We'll be very quick to respond. And also don't forget to like and subscribe our channel. If you have any extra email IDs, please do subscribe. Thanks for watching till the end. Let's meet in another question.